All right, nerds. So now we've learned about the different groups in the periodic tables, what they're called. Actually, we haven't really. Given them numbers, but they've got names which we'll cover about 2 videos from now. Now we're going to talk about the trends in the periodic table. So what we see happen as we move across and down or up and across the other way. So by the end of this, what you want to be able to do is you want to be able to identify how we can use the periodic table to make predictions about how something will behave. You also want to identify trends in the periodic table. Cool. And you basically also want to be able to tell us the properties of metals, non-metals, and some semi-metals. Now over here we've got mercury. He's in there because while he's a metal, he actually goes dead against the properties of some metals, or the properties of most metals. And we'll see that in a minute. Okay, so what you should already know is that rows, so which we call periods, and groups, which are the columns, indicate the number of electron shells and electrons in the outer shell respectively. We should have that still from year 9. The periodic table can be broken down into metals and non-metals and semi-metals, or metalloids. While we're at it, what that means is that helium, which is in period 1 and group 1, has 1 electron shell and 1 electron shell in that outer shell. Lithium, which is in group 1, period 2, or row 2, it has 2 electron shells and 1 electron in that outer shell. And if we go over to fluorine, it is in row 2, so it's 2 electron shells, and it is in group 7, as in VII, which means it has 7 electrons in the outer shell. So 2 electron shells, 7 in the outer shell. And that's how we can use it to predict that. Now, trends in the periodic table. Just quickly jot this down if you want. You don't need to copy this down square for square. If you just draw the general shape, you'll get what we're saying. So atomic radius, so how wide the atomic is. It increases as you go down. This makes sense. You get more and more, what are they called? More and more rows as you go across. And it increases as you go across this way. And that's because as you get over here, you've got more electrons and more protons than you do over here. So they pull in together, and that makes this one here, which even though it has fewer electrons, is wider, has a higher radius than this one. Metallic character, so how much the atoms over this side really fit the metallic properties, that's over here, and the least metal of all are over here. So these are the super metals, least metals. Slayer, Jack Johnson. All right, so when we're talking about reactivity, how well something reacts or how easily it reacts, for metals, this corner down here, francium that is, that's the most reactive of metals. This sort of corner, remember ignoring this last group here, which we'll talk about in another lesson, where fluorine is, the corner of fluorine is the most reactive for non-metals. So most reactive down here, most reactive here. Now it increases, the metals increase in reactivity as you go across to the left, non-metals increase as you go right, to the point where sodium or lithium, if you get lithium too wet, it'll start to fizz and react. You put sodium, which is just beneath lithium, in group 1, it will then ignite, and francium, you can't even get it near water because it explodes in the air. Fluorine is, so you've got chlorine here, which if you breathe in chlorine, it'll cause you significant damage. Fluorine will rip the electrons off your atoms super, super fast, super strong, causing massive, massive damage. All right, so that's cool. Here are our properties of metals and non-metals. So the appearance of metals is shiny, non-metals are dull. Hardness, metals tend to be very hard, whereas non-metals, they're usually fairly brittle, so they're not super hard. They tend to break when they're solid. Malleability, these guys will bend. You can hammer them into a flat sheet or a shape. Non-metals, they tend to not be malleable. It goes with brittleness. Ductile means to be able to be drawn into a wire, whereas non-ductile means you try and pull on it, it'll snap. Metals tend to be really good heat conductors and electrical conductors, whereas non-metals tend to be really bad at it. Usually, a metal is a solid. Again, not always. Usually, non-metals can be any of them, solid, liquid, or gas. They tend to be fairly dense, not super dense at all. And there's good reasons for this. These are generalized properties. Now, what that means is carbon, which is a non-metal, is a fantastic conductor of electricity. Mercury, which is a metal, is a liquid. Lithium, sodium, they're not super hard. You can cut them with a knife. So, yeah, it's generalized, but it's not always spot on. And if we go back to our metallic character, these ones over here, they fit the metallicness almost perfectly. And these ones over here, they fit the non-metallicness almost perfectly. And that's it. That was a short one today. See you in class, and we'll do some more experimenting.